doing something a little bit different. Now that we are remote, and we only have 30 minutes of class time, I still need to get through the whole lesson for today, and I don't want to just have you do one activity on your own. I only have one activity for each new learning target. So what we're going to be doing moving forward is I'm going to be pushing out to you guys videos of me actually recording and going through the second activity that you're going to be working on your own. So we're in this unit, unit 3, and we're talking about understanding proportional relationships. So we are graphing proportional relationships from a story, and we can use the constant of proportionality to compare the paces of different animals. If we remember, we said that the constant of proportionality is that constant rate of speed, right? How fast is this person walking? And we're going to compare these we compared in the first activity we did in class today, we compared the speeds of the ladybug and the ant. So in this next activity that we're going to be working on, we're going to be looking at these same two people, or well, animals really. And we're going to be throwing in another animal, and we're going to be looking at that rate of speed, and we're going to be comparing. They're going to give us a comparison to this new animal's speed and the speed of the ladybugs, and we're going to have to determine that new animal's rate of speed. So we looked at these moving ladybugs and ants, and if we remember, they had different rates of speed. And we're going to need to remember and refer back to those when we're going through. So please make sure that you have your textbook or those slides open for today. Obviously you have the slides open because you wouldn't have been able to get to this video unless you had your slides open. But we're going to be using the activity moving through representations to do this second activity here. So we went through and we found which line represented each one of these animals, how long did it take to travel 12 centimeters for the ladybug and the ants. Then we actually created this scaled graph here. Now we're moving into the second activity here. It's actually called activity number 3 because activity 1 was our warm-up, activity 2 was the first part of this, and so now we're going to be taking a look at this next activity, moving twice as fast. Okay, so once again, I said we're going to be dealing with this ladybug and this ant again, but we're going to be throwing another insect in this time. So let's take a look at what it's asking us to do here. So it says moving twice as fast, okay? So here we go. Imagine a spider is moving twice as fast as the ladybug. On each tick mark diagram, mark the position of the spider. So over here, I actually threw some spiders on here where we can place them where they would fall in each one of these tick mark diagrams. So if we remember, the thing about these tick mark diagrams is a little bit tricky, is that when you're putting the ladybug, the insect, the ant, or the spider on this tick mark diagram, we're always going to count from the head of the insect or animal, right? So we're going to count at that the head or the front of that animal. So this guy, his head is sort of in the middle. So we're going to be we're going to be placing his distance. When we're marking his distance, we're going to be using the far right side of the box. So if he's starting at the same spot that the other guys are, he's starting in the same spot. He's starting at that start line. His front of his box is lined up with that start line. I moved him over a little bit so that he's perfectly sort of lined up. So if he's moving twice as fast as the ladybug, first, what we need to do is we need to remember back. How fast was that ladybug moving? You can sort of go back a little bit. You can also refer to it here, right? Because we went from at this starting line here to now after 2 seconds, she was 1, 2, 3, 4 centimeters from the beginning. So if I'm looking at this guy right here, and I did this when we did this in class, so I'm just going to sort of write it out on my chalkboard here. So the ladybug, if we look at it, she moved 4 centimeters for every, not 1 second, because if we look here, she actually went from 0 to 2 seconds. So our change in distance is 4 centimeters. The change in time is 2 seconds. So it's 4 centimeters for every 2 seconds. But I want to figure out how far does she go every second? So if I look at it as a fraction of 4 over 2, I can simplify that. If I want to make it 1 second, to go from 2 to 1 second, I have to divide by 2. Divide my denominators by 2. So if I divide my numerator by 2 as well, because I'm dividing by the same number here, 4 divided by 2 is going to get me 2. Think about what your label is going to be. So the ladybug moves at 2 centimeters per every 1 second. So we can write that out as like a phrase of he walks a speed of 2. Sorry, Mr. Means markers are not working. 2 centimeters per second. Okay, and we can write that out as 2 centimeters per second. So we remember how fast the ladybug went. So the ladybug went 4 centimeters per second. So I'm just going to sort of write that on here for myself so I can remember how fast this ladybug goes. So the ladybug moves at 2 centimeters per second. Okay? So it tells me now this new insect is going to be moving twice as fast. So the new insect, or the spider, so I'm going to throw in this new guy here, the spider will be moving at 4, because if we're thinking it's double, what do we have to do when we double a number? We multiply by 2. So if we're going 2 centimeters per second, or 2 centimeters per second for the ladybug, the spider is going to be moving at 2 times 2, which is 4 centimeters per second. Ooh, but S-E-C-O-N-D, right? But I'm looking at these tick diagrams. These actually move at, these go 2 seconds. So if I know I go 4 centimeters per second, but I need to figure out how far that I go in 2 seconds, I would have to move that distance of 4 times that by 2. So in 2 seconds, he's going to move how many tick marks? So if in 1 second he moves 4 tick marks, in 2 seconds he's going to move another 4. 4 plus 4 is 8 centimeters per 2 seconds. Just so that, okay, 8 centimeters per 2 seconds. So now on this 2 second line, we're going to have to go 8 centimeters out from the start. That's 8 little tick marks. 1, 2, 3, 4, 5, 6, 7, 8. So he's right here. I'm going to grab my spider. Oh, Mr. Main, you definitely should have marked that a little bit better. 4, 5, 6, 7, 8. Very good. So at 2 seconds, he's going to have gone, 8 centimeters. Good. So then now, if I have to go 2 more seconds, so that means I went 8 plus another 8 more. 8 and 8 is 16. So I need to come back to the start and I need to count 16 out. 1, 2, 3, 4. 1 second. I'm going to grab him and count with him. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's how far he's going to be after 4 seconds. Okay, so now what I want you to do, we did the first 2 together. These should be marked on your diagram as well so that you know where the spider is going to be. So now I want you to pause the video and I want you to place where he's going to be at the 6 second mark. Okay, so I want you to pause because when you come back, I'm going to go through it. But I want you to pause it. I want you to place where he's going to be, grab him off this stack here and place him where he's going to be after 6 seconds. Okay, and pause. Okay, welcome back, guys. So we know he's moving 6 seconds. So he's been moving for 6 seconds now. So we know that 6 seconds is like saying 2 times 2 or 2 plus 2 plus 2, right? So 3 groups of 2. So if he moves 8 centimeters, 1 second, 8 centimeters for every 2 seconds, I can say 8 plus 8 plus 8. So 8 plus 8 plus 8 is 24. So he should be 24 tick marks from the start line after 6 seconds. Or you could say, how far is the ladybug? I need to take him twice as far. So if I start the ladybug, I know that the ladybug is 12 out. I remember back. So 12 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And look at that. He's right at the finish line. So I'm going to take my spider and I'm going to line him up with the finish line here. And the ladybug and the spider and the ants are done walking their little guys. So what you need to be doing is you need to make sure that you have your insect marked off where your spider is going to be at each one of those time frames. Make sure those are marked off before you go to the next slide. Okay, so now as we go to the next slide, it says plot the spider's position on the coordinate axis with lines U and V. Connect them to make a line. Okay, so we're gonna find some distances like we just did on that diagram. We know that at 0 seconds, time in seconds. Okay, at 0 seconds, we said how far was that spider? The spider's distance was 0. Yes, you're correct. So now what I want you to do is in this timetable here, in this little diagram, I want you to fill in. I want you to calculate what's the distance going to be for the spider after 2 seconds, 4 seconds, and 6 seconds. So I want you to pause the video and put those times in there for me. Pause. Awesome. Here we go. So we said that at 0 seconds, he was going to be 0 centimeters because he started at the starting line, right? So then after 2 seconds, his was double the ladybug. And we knew that the ladybug moved 4 centimeters per every 2 seconds. So if we double that, he's going to be 8 centimeters away from the starting line. And I'm going to come back up here and I'm going to give this a label of centimeters as well. And then we said 4. So 8. And then another 8 more. 8 and 8 is 16 centimeters from that start line. And then we said it was going to be 3 groups of 8 now because every 2 seconds he moves 8 and 6 seconds is made up of 3 2s. So it's 8 plus 8 plus 8, which we know our multiplication 8 times 3 is going to get us 24 centimeters. Awesome. So now we need to take these points here, oh my goodness, and we need to plot them on our graph on the next slide. So my suggestion, what I'm doing is, you can easily flip back and forth between these 2 slides. That's completely fine. I'm just writing them down for myself so that I don't have to keep flipping back and forth. So I'm just writing down 0, 8, 16, and 24 centimeters. I just wrote it like this, not a big deal. So now I'm going to come to my next point here, this guy over here. So we know that after 2 seconds, the distance so that when we went 2 seconds, this new guy is going to be, we have our first point is going to be at 0, 0. So 0 seconds, we're at 0 second, at 0 centimeters. So I'm going to put the point right there. It's kind of a little bit big, but it's okay. Then we know after 2 seconds, he traveled 8 centimeters. So we are going to go up to a lapse time of 2 seconds over to a distance that we found in our table is going to be 8 centimeters. So I'm going to put my point on up to over to the 8, and I'm going to connect them. Okay? Then we also know after 4 seconds, if we look at that table, it was going to be 16 centimeters from that initial starting distance. So I'm going to go up to 4 over to 16, and I'm going to put a point there. Okay, so then now, remember, we want to now, we have these points plotted. So now we need to grab a line segment and we need to connect these points. So that means you're going to come up into so you put these on yours as well. Okay, so these points should be now plotted on here. I want you to pause your video. Actually, no, I'm not going to have you pause your video. I'm going to have you grab this little line feature right here. And I'm going to have you click this little line feature right here. And I'm going to have you put it right on that point at the 0, 0. I don't know why that just happened. So once again, I'm going to have you click the line feature. Click on this little point at 0, 0. Make sure that it goes through your other 2 points that you plotted here, like this. I'm going to come over here. I'm going to make the line a little bit darker. So right next to this little pencil, you're going to click on the little 3 lines. And I'm going to change it to 3. And I'm going to change the color to orange so that I can see it really well. Okay? So I plotted this line on my graph. You also need to plot this line on your graph. Okay? Because we just plotted this guy here. And we have the line of our ladybug and the line of our ant. And now we have this line right here, which represents which animal? Our spider. Exactly. Our spider. So, we just plotted, kind of crazy, we just plotted this equation for this new spider right here. So once you have it, if you need to pause the video right now, you can, to connect your points, make sure they're on there, because I'm going to be checking back to make sure that these slides are done. Awesome job. Let's take a look at this next slide here. So pause if you need to, and then once you play it, we're going to be moving on to slide number 13. Okay, so now here comes the tricky part. Okay, so we just created the equation. We just created the lines. We just put our new animal on the tick diagram. Now, our last piece for this activity is we need to write an equation for each of the 3 lines. So remember that we use this form of y equals mx, right? And m is our constant rate of change, and y and x are our our y and our x are just those variables, right? So that y is going to be the time elapsed, right? So when we look at it, it's going to be y equals mx. And when we're writing equations, you want to write them, the m being that constant rate of change. So that speed at which we're walking. So our constant rate of change. I like to call it a croc. I know. Kind of silly. I know. It sounds kind of silly. But it's a croc. Constant rate of change. So once we're creating those equations, I want you to actually try to pause the video right now. And I want you to try to create an equation. I want you to take 5 whole minutes, or I want you to take 3 whole minutes. I'm going to put a little timer at the bottom of this slide here, and you're going to start that timer for 3 minutes. You're going to only take that 3 minutes. Don't push yourself any further than that. And then you're going to play the video back, and we're going to go through those 3 equations, okay? So hit pause and try to write an equation for each one of these 3 different animals. And wonderful, ladies and gentlemen. So we are looking at, we're going to look back at this graph that we created here. So we had a point at 0, 0. He's going twice as fast, so we took that distance and we multiplied it by 2. And we have our point here, and we have our 2, 8. And then we connected those with a line. I'm sorry, I know we did this already, but I wanted to just go through it one more time, just for the people in the back that maybe didn't get these answers out here. There we go. sorry guys. And we have our equation line here, and we need to write an equation for this graph here. So if we're looking at this ant here, so let's start with our ladybug, because the ladybug is a little bit easier. This is the one that we sort of started with. So when we're talking about that constant rate of change, we're talking about the change in we're talking about our slope triangle here, right? So like the m, so we have our y equals mx, and that m is as our constant rate of change or our slope. Okay, our CROC, our constant rate of change or our slope. So if we look at that equation here, and we're talking about this ant, so let's talk about this ant first, because remember the ant is line V. Right? So if I want to find my slope triangle, for every one that I rise, a rise of 1 over a run of 3 to get to that point. So we're going to have a slope for this one of 1 over 3. So this is going to be y is equal to, so for the ant, we're going to say y, or a variable, or the time, the t, the y is equal to, or we could also say the t is equal to, because we're talking about time. So the time is equal to, the y is equal to our rate of change, which is 1/3 x. So 1/3 of that value of our input, which is x, 1/3 our input of, instead, when we're talking about time this time, our input, our output, our answer, our y value is time, our input is d, our distance traveled d. So we could write it as y is equal to 1/3 x, or we could write it as y is equal to 1/3, or t is equal to 1/3 d. Okay, so then if we're looking at the ladybug now, and we go back, and the ladybug, if we remember, is this line u. For every 1 that we rise, we run it over 2. So that would have a slope of a rise of 1. So we could say y is equal to a rise of 1 for a run of 2, 1/2 x, or if we want to use those variables that sort of represent better the story we're talking about, we could say t is equal to 1/2 x. Okay, last one is the spider. So if we look at, and we want to find the rise and the run of the spider's line, we would rise it up 1, and we would run it over 4. So that one would have a rate of change of y is equal to 1/4 x, or if we want to use those variables that we've been talking about in this, that are closer to the story, we could say t is equal to the time. If we're looking at those scales on those axes, time is going to be equal to 1/4. Oh, wrong thing here. D is times our distance. Our distance times 1/4 is going to be equal to our time. So let's prove that by saying our distance is 4, our time is 1. 1 is 1/4 of 4. 1 is 1/2 of 2. 1 is 1/3 of 3. Okay? So these would be our equations here. If you didn't get those correct, or you didn't get them all written down, please make sure that you get those written down for yourself now, okay? So, if you were on this slide, I want you to pause it if you need to. This is like going to be my symbol for pause now. Like, pause, please. Like we're talking about like wolves, pause. Anyways, let's take a look at slide number 14, okay? So let's take a look at slide number 14. It says we need to plot another bug. So we're talking about, now we're going to be talking about a possum. I know it says a bug, but I love possums, and his name is Harold. So we have this possum who runs or goes 3 times as quick as the ladybug. So that means we need to plot some points on here. So we know that he's going to start at 0, 0 also, because like he's not a magician. He's just a possum. And we need to take that distance that the ladybug is traveling, and we're going to now need to multiply it this time by 3. So every 1 second that we go up, the ladybug goes over 2. So I need to take that distance of 2 centimeters, and I need to multiply that now by 3. 2 times 3, 2, 4, 6, is going to get me a distance of 6. So for one that I go up, I'm going to go over 6 centimeters. Okay, I can plot, you're going to do this along with me, so grab that point and put it right on that 1, 6. I mean, well, it's 6, 1, sorry, 6, 1. And then we're going to grab another point, and from there, we're going to go up another 1, because we're talking about the slope now. So we're going up 1 over 6, which would hit us right at that 12. So I'm going to hit this, so you have your 3 points on here, 0, 0, 6, 1, 12, 2. Okay, so now I want you to come over to the line button, and I want you to start the line right at that 0, 0. Make sure it goes through both of those points. You can continue it on if you would like. There we go. We can make it a little bit thicker, and I personally like to change the color because it's just more beautiful that way. Okay, so this is my possum. His name is, oh my God, I just forgot what his name was. Harold, I think it was. Harold? So I got my possum Harold. I had his line, his slope, instead of 1/2, like the ladybug, we take that and we multiply that by 3. So when we multiply that 1/3 by 3, 3 times as fast, that distance is going to be 6 for every 1 second. So it's going to have a slope of 1 over 6, 1/6. Okay? So if we wanted to create an equation for that line, we know that when we're talking about it, we can write it one of 2 ways. We can say y is equal to, this is more the simple way. So our time, if we want to use those variables that we've been talking about in this situation, we can say our time or our y is equal to, okay? And then we talk about that rate of change. And if we look back at our slope triangle here, we said we have a rise of 1 and a run of 6. So that gives me a slope, a rise of 1, a run of 6. Remember that we write slopes as rise over run. If I write it as a fraction, that would look like a rise of 1 for every 6 I'm going over, our slope of 1/6. So that would be written as y is equal to 1. Actually, stop. Pause. Go back. I want you to write an equation for this one. Take 30 seconds right now. Write an equation for this one. Pause it. Now we're going. So we have a rise of 1 for every run of 6. So if I were to write that as an equation, I could write it one of 2 ways. I could say y is equal to 1/6 x. Or if I want to use the variables from this scenario, this story, I could say 1t is equal to 1/6 d times our distance, right? Because if you're looking here, you're going to say your distance of 6 times it by 1/6 is going to get me 1. Okay? So this is the 2 ways that you can write this equation right here. Okay? So guys, I know this one was a little bit tricky. I know this was a little bit longer, but I think you guys are going to do well with it. I think you guys did do well with it. So what we're going to end every video off with is we're doing a code phrase. So what I want you to do is I want you to send me an email with the code phrase C3PO. So over break, I got some fuse beads and I made a C3PO. So send me an email right now. This is the code phrase. Send me an email, pause it if you need to, with this code phrase C3PO. Okay? Okay, so awesome job today, ladies and gentlemen. What I need you to finish off with for today is this last slide here called Turtle Race. Okay? It's our cool down for today. And if you're looking at it, you have let me just pull this up a little bit more, actually pull it out of the way. So you're working on this as a sort of cool down or exit slip for today. This graph represents the position of 2 turtles in a race. Plot points to show another third turtle. that is going half as fast as the turtle on line G. So you're taking line G's, and he's moving every 1 second, he's moving 2 centimeters. So if he's moving 2 centimeters, and if the other guy is going if the other guy is going half as far as him, and this original guy is going 2 centimeters for every second, if I say what's half of that distance, that new guy's new distance is going to be half of 2, which is half of 2 is 1. You're right. So for every 1 second, this new guy, you're going to plot a point. You're going to say for every 1 second, this guy, he can run 1 centimeter. Okay, so from here, if I want to rise and run, my slope of rise it 1, run it 1, I have a couple points here, and you might need to grab that line and connect it. All you need to do is create the equation line for this piece right here, okay? So, ladies and gentlemen, you guys did fantastic. I know this was quite a bit, but you guys are rock stars. Keep it up. Reach out to me if you have questions. I'm going to be running a group this afternoon for you to just come in and sit with me. I would suggest if you are struggling with this and you have not already watched already, please join that group. And please send me that email with our code phrase for the day, C3PO, C3PO. Awesome job, guys. Okay, I will see you tomorrow morning. Reach out if you have questions. Bye, guys.